Hello, welcome back to Cracking the Cryptic, and yeah, the big news this weekend that our classic Sudoku 2 app is out now and features some brilliant puzzles by both Nikoli and Sam Cappleman-Lynes. Nikoli, the original Japanese constructors of classic Sudoku, popularized it worldwide. Sam, who has literally taken the genre on in leaps and bounds. You may need the question mark, the little hint button for some of Sam's puzzles, because some of the techniques used, they're just fantastic. Have a look at those. There are some puzzles by us as well that you won't need the question mark for, but do get the app. It's fantastic value, 60 puzzles in time, and yeah, I mean, check it out on the links under the video. There are other apps, of course, such as Fog of War, but also such as the Worms by Phistomefel and James Sinclair, Marty Sears and Michael Lefkowitz. Check those out too. They're great. So is SVEN'S SUDOKU PAD, also linked under the video. And on Patreon, you can have a go at Put Out More Flags, our November monthly puzzle hunt, or 9 by 9 Sudokus, 7 of them, based on flags from around the world. Loads of people getting through them and sending in solutions. Join them and you might win the chance to collaborate with Simon on a video solve. There's also on Patreon crossword videos, myself tackling Knockout by Haribobs from The Listener recently, and connections videos. There's loads going on there. Do have a look. Right, we got recommended this puzzle by YMH, who's occasionally written to us before, a very reliable recommender. I have never heard of the constructor, who I'm going to pronounce as Signet. I think that is the French for a signet, a little swan. And I could be wrong about that. The puzzle is called German Palindromes, which I quite like. It invokes the notion of pen pals, which is a little oldie worldy, but good fun. Now, let's have a look at the rules and see what we're dealing with here. Normal Sudoku rules apply. That's 1 to 9 going in every row, every column, and every 3 by 3 box. Right, these are special lines. They're both green and grey. Digits along a green and grey German palindrome line read the same forwards and backwards, and adjacent digits have a difference of at least 5. Oh, so the line is both a palindrome and a German whisper. Each line is both a palindrome and a German whisper. And then there are some thermos, but they're slow thermos. Digits along a slow thermometer stay the same or increase from bulb to tip. So all that's telling us is that digit can't be lower than that one. Wow, that's it. That's all the rules there are for this puzzle. It's a bit of a feat to construct this, I would say, with one big line and a couple of other little lines, 4 tiny thermos in the puzzle, which I am not going to pencil mark. I know Simon imagines I will, but I won't. Give it a try on that first link under the video. I'm going to start now. Let's get cracking. This is puzzling. Why? I mean, these are utterly useless at the moment. If you were pencil marking one of these thermos, you would literally have to write, I think you'd have to write every possible digit. Every one of them could be 99. Then I'm not pencil marking those. Right. Is it the palindrome or the whisper aspect that is more helpful? Okay, the things we normally know about German whispers are that 1, you can't put 5 on them because there's no Sudoku digit that can go next to it. 2, you must therefore alternate between digits higher than 5 and digits lower than 5, otherwise you wouldn't be maintaining the difference of at least 5. And 3, the other thing is that in each position, sorry about the importunate buzzer man, 4s and 6s are quite difficult to place, because if they're in a cell, if you were to put 4 here, it just wouldn't work, because the only digit it can connect to are 9s on both sides, and they'd both be in the same box. Now there are places where you could put 4, like here, because you could put 9s there. They're not in the same row, box and column. So 4s and 6s, we call them monogamous digits because they only have one possible partner, are difficult to place. That's really intriguing. I'm just thinking about... Okay, so the first thing to do is to use the alternating function that I mentioned there. And to, I don't know, this is the first thing I'm doing. I'm not saying it's the only way to approach this puzzle. I'm going to colour the alternating digits, trying to not get them wrong. The fact that I've finished on the same cell as I've begun, sorry, that I've finished in the same colour as I've begun is encouraging. So if those are all pink, which could be low, but it could be high, then these are all green, which must be the opposite. And we have a line coloured like that. Now, are there places where we see all four colours, rows, columns or boxes? Because what we're doing here is choosing that either the pinks will be high and the greens low, or the other way round, and therefore there are only 4 high digits, 4 low digits and a 5 in each row, column and box. That's not the normal secret we teach you, but it is true. I can't find any rows, columns or boxes with all the same, with all 4 pinks or greens. I mean, I might be missing them so far. Still continuing to study this and not really getting it. Okay. Right, then we're going to have to use the palindrome function. I'm going to use letters. I think I'm going to use letters. So, well, no, now I have to choose where to start. Where to start lettering this that might be helpful. Oh, look, there are 4 pinks in box 6. Well, there's a clue, maybe. Well, I'm going to start there. Oh, where is the middle of the palindrome? I haven't worked that out. Am I going to have to count? I probably am going to have to count up all the... Right, let's count the length of the palindrome. I've put this off for too long. Well, first of all, I'm just going to count the number of pink cells and then subtract 1. Well, that's going to be the odd, sorry, not the odd positioned digits along this. 1, 2, 4, 7, 8, get on with counting, 10, 12, 14, 17, 18 pinks. Because pink is on the end and green must be in the middle, there's probably 17 greens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 15, 16, 17. So the line is 35 cells long. So the middle cell is the 18th cell. 2, 4, 6, 8, 10, 12, 14, 16, 18. This is the middle. I'm going to put a little circle in that cell to remind myself that that is the center. And that means these 2 digits must be the same. These 2 must be the same by the palindrome, etc. But, yeah, I'm going to start by labeling A, B, C, and D in these pink cells in box 6. And then working out if that is going to enable me to label the rest of the digits in pink. So 1, 2, 3, 1, 2, 3. That is the equivalent of A on the palindrome. Then C is 2 further pinks away from the middle. That's there. B is the next one, and D is the next one. I'm looking at this line, and I'm sort of pushing out from the middle. Right. What is that telling us? It's telling us some things. This cell sees A, B, C, and D. Ah, this one is pink. And it sees B in the column, C in the row, D in the box. That's A. Then I can label A on the palindrome. It's the 3rd one from the end. It's just after D as we go out. It's there. Now. Ah, hang on. There's a 4th pink in this row. And it's not in those 2 cells because box 6 has used up its pink allocation. So it's here. Right. So now we've got the 4 pinks in box 4, and those 2 are a BC pair, and this digit must be A in the row. And then that's A by palindromic logic. I don't know if, yes, I do know that palindromic is an adjective. Now, B and C include that cell, which cannot be C. It's that one is equivalent to that, and that C is a C in its column. So that's B. This one is C, and that's not on the palindrome. This one sees ABC. That's a D. That's on the end of the palindrome. That's there. Okay, this technique is good. I didn't know if it would be. This digit sees B and C. It's equivalent, I think, to that one which sees A. So those are Ds. And now I've labeled all the pink digits on the palindrome. Do I move into the green digits, or do I try and solve? I think this is weird. I've now worked out, it's probably very obvious to several of you first. It is going to be the thermos that disambiguate high versus low in this puzzle. It's the only thing that'll do it, which is weird. Oh, maybe I need to look at... Okay. This central digit on this sort of 4 o'clock palindrome, pen palindrome, whatever it is, it's not pink because A, B, C and D have been used in this box. It can't be the number 5, so it must be green. So we must then alternate, even on this little palindrome with this little German whisper with pink cells, and this one sees B in the box, B in box 1, A and C in row 5. So that's another D. I've probably got almost all the Ds. I can put D into box 3. That's all the Ds. They're all done in the puzzle. C in box 5. I'm going to try and label up B's and C's. Oh, look, this is an A-B pair. This digit is where B must go in column 8. So that is a pink B. And on the palindrome, obviously, there's another pink B. And this digit is green. Okay, once I've done this with B's, A's, C's, and D's, I'm going to try and letter the greens as well. So, what else? Now I'm trying to find pink cells off the palindromes. So C in box 9 is in one of those. No, C in column 8 is in one of those two cells. This sees A, B, C, and D. So it's either 5, which is an uncolored digit, or green. Oh, maybe it's time I found some green. Right, 5 in this row is in one of those two cells. I haven't really thought about 5s yet. Let's have a think about 5s. 5 in box 4 is in one of those two. 5's in one of the... I don't know, 5's not being actually all that helpful. Right, C in this box can't be in those cells, and it can't be in green, so it must be in one of those two. Then C in this box is in one of those two. And these are the remaining positions for C. No, there's a C somewhere up in box 1 and another one in box 3. Okay, that actually was not all that helpful. How are we doing on A's? I can place A in column 1 in the corner. That's A in the corner, and then there's the last A in the puzzle. Okay, that's good. How about B's? We need a B in one of those two in column 1. B either there or there in box 8. Oh, B definitely here in box 5. Well, that's good. That's going to sort out all the B's, I think. We can get rid of that, and that's definitely B. Then we can get rid of that, and that's definitely B, and that's probably all 9 B's in the puzzle. So it's only C's we're left wondering about in the A, B, C, D group. Right, I have promised for some time that I was going to now look at the other digits. So where have we got a little cluster or preponderance of them? I think box... Oh no, that's not on the long line. I want to find, okay, these three in row 8, they'll all have counterparts. So let's call them E, F, and G. And then we try and map these onto the palindrome. G is the first green digit on the palindrome, so it's there. F is the second one out from, in fact, E and F are the first two out from the center. So that's E and that's F. Now, E, F, G, and H are going to be my letters for green, if this works. I'm not sure it's going to, is it? This one here sees F and E. Okay, I may have chosen badly in trying to start my labeling down here. Let's go backwards a bit. Let's back up and try and choose somewhere else. There's 3 on the long palindrome here. I'm going to do that instead. You may think it's going to look remarkably similar, and maybe it will, but I'm going to try those as E, F, G. Then that's G near the beginning. E is the first one after the center. Then there's a gap, which is there, and then F there. You see, that is more useful, because now by Sudoku I can fill in F in box 8, and that's there, and then I can match that on the palindrome. So I've got a little bit more done there, and that might make all the difference. Let's see if it does. What I really want to do is find an H. Oh, and then I want to find which of either green or pink is going to have to be in a monogamous digit. Yeah, I think that's probably the way to go. Sorry, I'll talk more about that when we get there. F's in one of those 2 cells. E is in that cell in box 8. It has to be. That's interesting to find one off the palindrome. There's an E in one of those 2 cells as well. Now we've got more F's to find. F is in one of those 3. This sees G and F. This sees E and F. Okay, so I'm going to put GH as the candidates there. I don't know. Am I missing the point here? Possibly I am. Wow, I don't know. I'm not going to try a third colouring scheme. Although now I'm tempted by this one down here. Neither of those can be E. That's quite interesting. Oh, of course, there are positions on the palindrome that occur in 2 places. So that digit is the same as that. I hadn't even thought about that. And that's perfect. This sees E in row 9, F in row 6, and G in column 2. So that green digit is an H. Now we get a G in the center of the palindrome. Now, this next one, that's here. That sees E in row 5, G in row 7, H in box 4. So that's an F. This is an intriguing way to go about this, isn't it? This one sees F and E in the row and G and H in the column, so that's G. And where's that on the palindrome? That's there. Then there's one more cell on the palindrome. It sees H, G, and E in the columns that it's in, so that's an F. Now, this one on this palindrome sees E, F, and H, so that's G. This one on this palindrome only sees F, so I can't fill that one in. But now maybe I've got the wherewithal to do some Sudoku. E there says this is E and 5 now, and that's H. Might as well green it. And this is 5 in the row because there's no room for anything else. This is E, I think, in the box. These are B, C, H. No, we've had B. They're C, H, and 5. I don't know the order of those. Okay, let's put CH5 in as candidates. There we go. That 5 means that these two are C and H. The bottom one can't be H, so that's C. The top one is H. That's C, that's C. That's all the C's. It's not all the C's done. I've still got 3 of them left, but it's more C's done, and I could colour them pink as well. The H is green. Now we've got, that's not F, we've got E and 5 to place. This one has to be 5 because there's an E in the column, I think. And then that one can be E. E is green. This must be G now because it sees the other green digits. That must be 5. Because that's the thing we haven't placed in row 2. That's a 5 in column 3. This pair is E and H, isn't it? Yes. E, H, and they're both green. This is also green and is G. Got E and yes, E and H. That one, I thought I could see H and E down there, but one of them's F, thank goodness. That's E. This is H. We've labelled all the first 3 rows, and row 5, funnily enough. Still can't do that 5 and E, but this column, that's G in the corner. That's G in the spotlight. There was only one left. Then we've got 5 and F in this row. That one is F, last one in its column. This is a 5. 5 doesn't get a colour. That's now not a 5. These are C and H. We must know the order we do. C and H. That sorts out all our C's. That must be 5. That must be H. Oh, the colouring's gone wrong there. Why have I coloured all those purple? I don't know quite what I did to achieve that. It was clearly wrong. I don't know when I did it. Oh, look, we've got HH on a thermo. 5 and E, those are not resolved. These two are, one of them is H, that's there. The other one must be 5. Again, we're finishing off the 5s. That's a 5, that's a 5. So this is E. This is, these C's are pink. This is green E. And again, it's the same digits. That's okay on a slow thermo. Right, now we've got in position to somehow use these slow thermos to determine which is, okay, the thing I have not done, I talked about doing this and then forgot, is to try and locate which of either A, B, C, D or E, F, G, H, which is monogamous. Where are we allowed a 4 and where are we not? Here we go. This can't be... Okay, I can tell that that is going to be the monogamous digit, 4 or 6 in this box, and I'll tell you why in a moment. But I think maybe what I have to do first, look, 5 is not the same as A, and it is therefore less than A. So now we know that A, B, C, and D are the high digits, just because of that thermo. This one also proves that H is on a bulb of a thermo which has a 5 on, so H must be low. So I'm going to make the greens into blues and the pinks into oranges, because the pinks, the oranges now, are the high digits. Now this is where I deploy that this cannot be 6, because those would both have to be 1. This can't be 6 because those would both have to be 1. This can't be 6 because those would both have to be 1. So all C's are 6. And surely there's 1 on the palindrome. There is only 1 on, no, there are 2 on the palindrome. Anyway, this one is touching those cells. So F has to be 1 because 6 can only touch 1. And you see that works up at the top here as well. So we found all the 1s. Now, can I find the blue digit that can't be 4. It's either E, G or H. G can't be 4 because B and D would have to both be 9. H can't be 4 because A and B would both have to be 9. So E is 4. And on the palindrome, that's touching A. So A is 9. Now I just have to disambiguate 2s, 3s, 7s and 8s. And we're actually done. How are we going to do that? We're going to find somewhere that touches the 2 remaining letters of a particular colour. And whatever digit that is, that's what I think we're going to do. Right, here we go. B touches both H and G. Now, H and G are low. They're 2 and 3 in some order. If B was a 7, it would definitely be touching a 3, either H or G on the line, which is not allowed because 7 minus 3 is only 4. So B is going to have to be 8 in the high digits, and therefore D is going to be 7. And now G can't be 3 because it does touch a 7. G must be 2. H must be 3. And we're actually going to just finish the puzzle with this last substitution. And it's incredible how quickly in one of these sort of colouring and lettering puzzles you can suddenly put in all the digits. I suspect I have been 20 minutes putting in a few 5s and all the letters, and then 3 minutes to put in the other 72 digits or 72 or more digits. And there is the solution. That's very clever. It's a very clever puzzle. It's not actually as, I think I made it more difficult than it was. It's intriguing how these slow thermos, 2 of which, I don't know that I ever used them. It just turned out they had the same numbers on. But these 2 were either of them would have been enough to determine which was high and which was low. Very nice puzzle, Senior. Lovely to see. No ugly duckling here. And that's most enjoyable. Super puzzle. Thank you so much for watching us on the channel. I hope you saw your way as to how to get through that yourself. I'm not saying I found the only way, but I think I found the intended way. Who knows? Thanks for watching. I hope to see you soon again on the channel. Absolute pleasure to be with you. Of an evening, and bye for now.